You want your unit circle, and you're welcome to have your identity sheet out, but I'm going to show you a few things with your identities. All right, so let's look at part A. So for part A, we have the cosecant squared of theta equals the cotangent of theta plus 3. Right? And then number 1 says rewrite with only one trig function. So if we have a cosecant and a cotangent, we want to try to rewrite it so that we only have one of those equations. And since today we're going to solve using identities, let's look at our identity sheet. Okay, so let's look at our Pythagorean identities. Are there any identities there that are going to relate the cosecant to the cotangent?
Yeah.
Yeah, okay, so 1 plus the cotangent squared is going to equal the cosecant squared. All right, let's write that down. So we know that the cosecant squared of theta equals 1 plus the cotangent squared of theta. And what are we going to do with that value? Because the left side's already squared, right? What can I do with this? Plug it in. Plug it in, right? Okay, so if you have the cosecant squared equals 1 plus the cotangent squared, let's just substitute it into the equation. So now, instead of cosecant squared of theta, we're going to have what on this side? Yes. Okay, so go ahead and substitute that in. Okay, so what we're doing is we're taking this value and we're going to be plugging it into this part of our equation. Okay? Okay, so let's see what that looks like, and then we're going to try to solve. Oh, man. That messed up.
Have a sweet background.
That's every background.
Oh, yeah, you like that background? Pretty sticky. All right, now once we get here, does anybody have any ideas on where we're going to go next?
You put it like sides.
Okay, so Kenzie, why would we say again what you said?
Put them on the same side.
Yeah, okay. Do you know why we're going to do that?
Because you can.
Well, we can. Well, why is that going to be helpful?
Yeah, which is
Factor, yes, we can factor, right? So we're going to move everything to one side. That way, we're going to have 0. Our equation's going to be equal to 0. And then we're going to factor. Right? Now, I chose to move everything to the left side. Why did I do that? Good. I want to keep my cotangent squared positive. So I'm moving everything to the left side. Now, if you have trouble factoring with the cotangents, why don't you try rewriting it with x squared? Because what type of equation is this? Quadratic, right? It's a quadratic equation. Okay, so go ahead and factor. So you try to do that. Yeah. Yep, so you're moving everything to one side.
okay. I was trying to put.
No, that's nice too. See how you have the 1 here? Okay, so now we're going to factor. Okay, so you guys factor. Right, x multiplied to -2. Okay. Okay, and once you factor, see if you can do the next step, because it's actually really similar to what we did yesterday. Okay, so Samantha, did you already factor this? Sam, did you already factor this? Okay. That's okay. When you got it, let me know. Yeah? Uh-huh. Well, the whole thing's equal to 0 here, but then you can take each of them separately. Yeah? Do you know what to do next?
Oh, -1 should be.
Yes. So you can find that. You can find that on the unit circle. Well, that's actually what's positive. All students take. That would be positive, so not in 3. Because it's positive.
We want it positive? Or
No, because it's negative.
oh,
Right.
but that.
Yeah.
Okay.
Yeah, exactly. Okay, so Sam, did you factor it? Uh-huh. Yes, good. Okay, now this is the zero product property. We know that those two multiplied together equals 0, that one of those has to be 0. So we're going to go ahead and set each of them equal to 0 and then solve. So I hope you went to that next step without me. That's absolutely something we know how to do. Okay, and then once you get here, you're going to solve for the cotangent. Now, are there places on the unit circle where the cotangent's -1? Yeah, okay. Remember, cotangent is x over y. You could think of it like that, or remember what we did yesterday? Are we going to be able to find 2 on the unit circle for the cotangent? No, so I have to use the calculator, the inverse on my calculator. Do I have an inverse cotangent on my calculator?
No, you can make it though.
So I'm going to have to use tangent. Yeah, so Alex, tell me what we have to do.
1 divided by the inverse.
Okay, so you can think of it as 1 divided by the tangent, right, which is the reciprocal, or you can change them both to reciprocals right away. So what is the reciprocal of 2? 1/2, right? So the reciprocal of cotangent is tangent, reciprocal of 2 is 1/2. Now with this one, what's the reciprocal of -1? It's -1. Okay, so I wrote reciprocals here. You might want to make yourself a note too, just in case you forget, because these are the same values. 1, the reciprocal of 1 is 1, the reciprocal of -1 is -1.
I just put reciprocal.
IPROCALS. Yeah, then you might put an S in there. Sip for sip.
Well,
All right, so I hope you have out your unit circle. So we're going to try to find where tangent is -1. Remember, you only have to find one place. So you know if it's 1 here, you can use the reflection. That would be -1 there. Okay, yep, so 3 pi over 4. And remember, it's tangent. Okay, so Reagan, every time we have tangent, what do we add to it?
K pi.
Yeah, k pi. Okay, now for the next one, we have to use the inverse function on our calculator because there's no place on the unit circle where the tangent is going to be 1/2. Okay, and then once you finish that, go ahead and start thinking about part B.
So that's 3 sine squared?
No. Oh. I think.
No, there's 2 theta. 3 sine of 2 theta. Okay, so for part B, you have 3 sine of 2 theta. So it's not squared, it's of 2 theta. And then minus 2 sine of theta equals 0. Okay, so I want you to look at that and see if you can tell if anything's different about it.
I'm gonna watch this.
No.
She probably see, I can't do it when she's talking.
Hey, wait, is Sophie's bed really comfy? Isn't it? Yeah, I know, dude. Jackson told me I couldn't go upstairs, but I did anyways. I know, I laid in Sophie's bed.
Really comfy to have like memory something on it.
Yeah. Oh, the roof is where it's that's where I sleep most of the time.
I'm gonna have to check that, but I want to double check it. Okay, so Cal, put that away. Guys, can you stay focused, please? Everybody. So 3 sine of 2 theta. I asked you to look at this and figure out what was different about it. Okay. Yeah, Jake, can you come?
Because there's a K value?
There is, right? There's a value in front of theta. So you have the sine of 2 theta. Do you guys remember what this is? It's the, yeah. You think? Okay, yeah. Remember the double angle formulas? So if you have the sine of 2x, that equals 2 times the sine of x times the cosine of x. So what we're going to do is we're going to substitute this into the equation. Okay, so we're going to substitute, and I wrote out for you exactly where this comes from. So this is an identity. Here is the identity. So now I'm going to substitute the identity into the equation. Okay, so now we're going to simplify. So you don't distribute this because there's no plus or minus sign in between these. You just have to multiply. So when you multiply, you're just going to multiply the numbers by the numbers. And then from here, we can, I know you guys probably already saw it, but what can we do? We can factor. Okay, so in this case, we're going to factor out what they have in common. So I want you to try to factor out what they have in common. Okay, so we want to know what these have in common. Rachel, what's one thing they have in common? Or you can just tell me both of them. Yep, and? Yep, 2 and sine. So if I factor out 2 sine of theta, then in the first one, 6 divided by 2 is 3. If I divide sine cosine by sine, I'm going to be left with cosine. And then if I divide 2 sine of theta by itself, I'm going to be left with a minus 1. Now, once you get here, you can just solve each one equal to 0 and solve. So go ahead and do that. Keep in mind, whenever you can use your unit circle, you want to use your unit circle because you want an exact value. And if you can't use your unit circle, that's when you're going to find the value in your calculator. Okay, so go ahead and do that now.
You know that. Things do good.
Where were you when there was a car and mud?
The trail, the Myers and Beth.
Okay, so for the first one, you got sine of theta equals 0, and there are two places where sine is going to be 0. Okay, tell me what two places are going to be. Okay, good. So there's 0 and pi. So if it's 0 and pi, they're how many degrees away from each other? 180. So that means that I only have to write one of those. Yes. So I chose the 0. So 0 plus pi k or k pi is just going to be k pi. So that's going to be one of our solutions. Okay, now if you wrote, like on a test or something, pi plus k pi, that would be fine as well. Okay, as long as you just have either one. I'm always going to pick the lowest one, the lower value.
This is probably dumb, but if you like just leave the 0 there.
No, that's fine.
Okay.
Yeah, that's fine. Okay, and then for the next one, that's where you're going to have to do the inverse, because there's nowhere on the unit circle where it is 1/3. So if you guys didn't do the inverse yet, will you do that, please? And that's going to give you one of your answers.
Why do we have to do the inverse again?
That because there's no place on the unit circle where cosine is 1/3 exactly.
So why would we? I'm just asking why we use the inverse and not like normal cosine.
Oh, because when you're using the inverse, that's when you're finding the angle.
Oh,
If you're doing normal cosine, that's when you're finding your point. Yeah. Okay, so you should get 1.23. And then again, remember, because this is cosine, you have to find the other one. So when we're thinking of the cosine, it would be helpful to draw a picture. Okay, so if we draw a little picture about what's happening here. Yes. Okay, we're trying to find where cosine is positive or negative. Okay, where it's positive. So we have 1.23, that's in quadrant 1. How do I know that's in quadrant 1?
Pi divided by q
Is
1.57.
1.57, okay? So I know it has to be in the first quadrant. Now when I do this, I'm just estimating where this is. So if it's 1.23, I'm just going to say it's closer to 1.57. So I just kind of put this somewhere here. I'm not putting it at an exact radian value. Okay, so I'm just estimating. So I know if this value here is 1.23 and it is positive, 1/3 is positive, the other place where cosine is positive is going to be in quadrant 4. I know this length is also 1.23. So if I'm trying to find the angle that starts at 0 and goes to this point, how am I going to do that? Good. 2 pi minus the theta value, which is 1.23, and then I will find my other value, okay, which is 5.05. So for these, when I'm writing my solutions, am I going to write plus 2 pi k or plus k pi?
plus 2 pi k.
Plus 2 pi k, or, yeah, 2k pi, either one.
Yeah.
And if you're unsure why that is, again, look at the picture. This is where my 2 points are. Are those 180 degrees from each other? No. Okay? So if they're not 180 degrees from each other, which you can see here and here that they're not, then you're going to do the plus 2k pi. All right. You guys ready for the back? All right. So for example 2, it tells you an equation is given. And we have to find all solutions for the first step and find solutions in a given interval for the second one. Now, notice that whenever it says all solutions, that means that's when you're adding pi k or 2k pi. And then if you're finding solutions in a certain interval, you're finding specific solutions that are restricted to those values. So, see how the 0 is included with the brackets, but the 2 pi is not? Yeah, they're the same thing. So if your answer is 0 or 2 pi, you're going to use 0, because 0 is included and 2 pi is not. Right? They're the same place on the unit circle. Okay, so this one is different, right? I have the 3 theta here, but do we have any formulas that are triple angles? No, not that we've learned about. So what we're going to do here is we're going to solve, but for the sine of 3 theta. So we're going to get this by itself. So I'm going to subtract the 1, and then I'm going to divide by 2. Okay, so then I'll have sine of 3 theta equals negative 1/2. Okay, again, subtract the 1, divide by 2, and that's how I'm getting this equation. Okay, now, what is the only way I can separate a trig function from whatever it's of? I have to use the inverse. So what I'm going to do is I'm going to do the inverse. Now, is this value on the unit circle for sine negative 1/2? Okay, so I'll give you a few seconds to look that up. So I want you to look up on your unit circle where the sine values are, negative 1/2, and then write those down.
Both of them?
Yeah, find both of them. Okay, so Haley, what'd you get?
11 pi over 6 and 7 pi over 6.
Good. So 11 pi over 6 and 7 pi over 6. How do we do with that? Okay, good. So these are our 2 values. Now remember, it's not theta equals these values. It is 3 theta equals these values. So what we're doing here is we're solving for this equation on this interval by using our unit circle. Now, it's just like if you had 3 times x. If you want the x by itself, if you want the theta by itself, what are we going to do to both sides? Divide by 3, which if you have fractions, it's easier to think of it as you're also what?
Multiplying by reciprocal.
Yeah, so multiplying by 1/3, which is the reciprocal. So that's exactly what I'm going to do. Okay, so I want you to multiply 7 pi over 6 by 1/3 and 11 pi over 6 by 1/3. Okay, so if we were just stopping here with theta, we'd have 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. But because we had the 3 theta, we are going to multiply by 1/3. Now, when you do that, Kenzie, what'd you get?
7 pi over 18 and 11 pi over 18.
Okay, good. So 7 pi over 18 and 11 pi over 18. How'd you guys do? Right? Good. Now, because these are going to be plus 2k pi or 2 pi k, we also have to divide those by 3. Okay, so we also have to take that value and divide by 3. Okay, so if you want, you can think of it as you're taking this whole thing and multiplying by 1/3, and then you have to distribute it. Right? So if you distribute it, then you'll get 7 pi over 18 plus, I wrote 2/3 pi k. I don't care if you write it as plus 2/3 pi k or if you write it as 2 pi k over 3. Either one of those will be perfectly fine. Okay, so the main thing is you do have to make sure that you distribute it to the period value here. Okay, so 2 pi k divided by 3 is 2/3 pi k. And that will be your final answer for step 1. Okay, but now we have to do step 2. Okay, which are we ready for? Okay, so what we're going to try to do is find all values from these 2 equations that are in the interval 0 to 2 pi. Really, how many answers are in both of these equations? Yeah, an infinite amount, right? So we're narrowing it down to just the ones that are between 0 and 2 pi. Well, because I have a fraction here, it's a lot easier to determine whether or not these are in the interval if we make this equivalent. So we can keep this 0, but instead of 2 pi, let's make it a fraction so that it's over 18. So what would have to be the numerator that would be equivalent to 2 pi? 36 pi, right? Because 36 divided by 18 is going to be 2. Right? Does that make sense that these are equivalent? This is just in fraction form. And I'm going to show you why thinking about that's going to be a little bit easier. Now, if I want to find everything that's in the interval, just like we did yesterday when we were finding the specific solutions, do you guys remember what we did first with the k value? What did we plug in? 0. So if you plug in 0, all right, then Megan, see, what are we going to be left with? So this whole part would be 0, right? Yep, so 7 pi over 18. So we want to ask ourselves, is 7 pi over 18 in our interval? Yeah. Is 7 pi over 18 less than 36 pi over 18? Yes. So this is going to be one of our solutions. Do you guys remember yesterday how we found the next one?
You kept adding 2 pi.
Yeah, you could just add 2 pi. So now what we can do is we can just add not 2 pi, but
36.
2 pi over 3. So 2/3 pi. But see how this is what we're adding?
Yeah, I see.
So it's kind of like you're plugging in what value for k? It's like you're plugging in a 1. So if you plug in 1, then you're adding those together. But of course, I'm not going to add these until I have what?
Common denominator.
Common denominator. Okay, so Emily, what's my numerator going to be? Good. Okay, so times 6 here, so times 6 here, so it'll be 12 pi. So really what I'm doing is adding 7 pi plus 12 pi, which will be what? 19 pi over 18. Okay, is that in the interval 0 to 36 pi over 18? Yes. Okay, so Simon, what am I going to do after that? So now it's like we're plugging in a 2 here, or we can just add 2 pi over 3 again. And we can keep doing that until we find every single point that's in the interval. Now instead of adding 2 pi over 3, I'm actually going to add the 12 pi over 18 so I don't have to keep converting. Okay, so if I add that, 9 plus 2 is 11, carry the 1. 31 pi over 18. Is that in my interval? Okay.
It's not going to work then.
Yeah, we know it's not going to work for the next one because what are we adding to this?
12.
12, and it has to be less than 36. So for that equation, those three values are going to be from 0 to 2 pi. Now we also have the other equation, which starts with 11 pi over 18. So 11 pi over 18, that's in the interval. So that's our first one. And then what are we going to add to that? Good. Yep, you're just going to keep adding the 12 pi over 18, which remember is equivalent to the 2/3 pi. We just want the common denominator. Okay, so then when we add those, what do we get?
23.
Good. 23 pi over 18, is that in our interval?
Yeah.
Yep. Okay, so then let's add 12 pi over 18 again. What do I get there?
35 pi.
Yep. So then, do I even have to add another one to know?
No.
No. Okay, since if we add 12, it's going to be way above that. All right, so how many solutions did I find altogether? 6. Okay, so there are 6 solutions in that interval. There are not always that many, which you'll see with the next one. Oh, you'll see in the next one.
I'm checking that.
I know, that is a long and doesn't have time to put it away.
I never was there. Never done it.
I'll come after school and I'll show you how to read a book.
This is cool as we're both just chilling right here.
Yes, but somewhere where you're not going to be tempted. Alright, so for part B, tangent of theta over 4 plus root 3 equals 0. And this is tangent.
She makes it look so easy.
Okay, so what are you guys thinking we want to do first?
No.
Yeah, roof, and I'm like, all right, well, I'll pack it up.
Okay, so the first thing you want to do is get the tangent function by itself. Okay, so if you're getting the tangent function by itself, it should just be negative root 3. Okay, so the first thing that you should have done is subtracted over root 3. Okay, and this is usually what people do incorrectly. They multiply by 4 at this point, but you have to do something before you multiply by 4. Yeah, you have to do the inverse. Okay, so what you should be asking yourself is, where is the tangent going to be negative root 3? Now remember, tangents are not on your unit circle, but we should have the first quadrant memorized, right?
Root 3, 1, root 3 over 3.
Okay, so you're going to have root 3 here, which I know is positive, but then where's the negative one? Just reflected. Okay, so it's right here. So this is at pi over 3, so this will be at 2 pi over 3. Okay, so theta over 4 is going to equal 2 pi over 3. And once you get your radian value, that's when you multiply. And you actually might want to make a note that you don't want to multiply until you have a radian value. Okay, so you don't want to multiply until you have a radian value. Because like I said, that's probably the most common mistake that people make on their test. Okay, so we are going to multiply by 4. Is that too fast or is that okay? Okay. Okay, and then why don't you guys see if you can write the final answer. No, because you divide by 4. Before we have to add, yes, and then okay, good. So did you guys get 8 pi over 3? All right, and then Susanna, it was plus what on the end? Okay, good. So how do you know it was k pi? Good. So it's tangent. So if you have the plus k pi, remember you want to take that and multiply by 4. So because you multiplied this by 4, you also want to multiply the k pi by 4. So your final answer is going to be 8 pi over 3 plus 4k pi, or 4 pi k. Yes, Regan?
Why wouldn't 5 pi over 3 be 1 too?
Well, it is, but with tangent, you only need one of them.
Oh.
And
Okay, yeah.
especially when you're finding the ones on the interval from 0 to 2 pi, you want to take the lowest one, or else you'd have to remember that you could subtract,
Oh, okay.
and there could be a value in there. So that's actually a really good point. Okay, so like I said, I always take the lower one. That way when I'm finding my other points, I won't have to add and subtract, because you could do that. Now, when we're doing step 2, now the denominator is 3. Yeah, so 6 pi over 3 is going to be equivalent to 2 pi. So there's no answer that's in that interval, right? Because 8 pi over 3 is bigger than that. So for step 2, it's going to be none. What's that? You could subtract it, and then and that actually might be a good thing to add in, right? If you try to subtract it, the 8 pi over 3, if you did the minus the 4 pi, then again, you'd still want to get a common denominator, so it would end up being 8 pi over 3, exactly. But that's a good thought, right? So, okay, that wouldn't be in the interval, but if it was positive, it would be in the interval and it would work. Okay, and then your homework is at the bottom there. So what's the least number?
What? No, that's like
9.
3, 5, 7,
9.